means total energy means potential energy plus kinetic energy. The sum of the potential energy and the kinetic energy is constant. Is constant. We are going to prove that for a body falling under the gravitational force. Now let's start the calculation. Let us consider an object is kept at a height of h from the ground and it is at the static condition. So the kinetic energy at the point A of the object is 0. If the mass of the object is m, then the potential energy at the point A is equals to mgh. Now the mechanical energy at the point A, that is equals to the kinetic energy at the point A plus potential energy at the point A, that is equals to 0 plus mgh, that is equals to mgh. That is the mechanical energy, total energy of the body falling under the gravitational force. Now let's move to the point B. Move to the point B. At the point B, we consider that it has crossed the height of the x and it is at a height of h minus x from the ground. Now what is its kinetic energy? To find its kinetic energy, first we have to calculate its velocity at the point B. Now we know the formula v square is equals to u square. Here u is the 0 because it is initially at the rest position. So 0 square plus 2g and the distance covered is x. So 2gx. So we have v square is equals to 2gx. Now the kinetic energy at the point B is equals to half m into v square. Now that is equals to half m, v square means into 2gx. 2 to cancel out, we have mgx. Okay. Now we have the kinetic energy at the point B is kinetic energy at the point B is mg into x. Now it is at a height of h minus x. So the potential energy at the point B is equals to mg into h minus x. Now the mechanical energy me at the point B is equals to the sum of the kinetic energy and the potential energy. So the mgx plus mgh minus mgx cancel out, that is equals to mgh. Now relating to the first calculation, we have the total energy, that is the mechanical energy is mgh at the point A and the mechanical energy at the point B is also mgh. So we see that throughout its motion the body has the mechanical energy constant throughout its motion. So a freely falling body have the total mechanical energy constant. To move our second topic. That second topic, what is the second topic? A body on the inclined plane falling under the force of gravity. Now we have to prove the total mechanical energy is constant. Now let us consider the point C. The mass of the object is m. So the potential energy, that is the gravitational potential energy at the point C is mgh. Why mgh? Because the body is situated at the point C at a height of h from the ground level. Now uh, what is its kinetic energy? It is at the static condition at the point C. So the kinetic energy is 0. And the total energy, that is the mechanical energy at the point C, is equals to the potential energy plus kinetic energy. That is the mgh plus 0. That is equals to mg into h. That is the mechanical energy. That is the total energy at the point C. At the point C, total mechanical energy at the point C. Now let's move to the point B. Let us consider that point is B. Now here we have to find the velocity of the object. How to find the velocity of the object? The acceleration due to gravity is acting perpendicular to the AB. Now that angle is theta, and similar to that angle is theta, and we have the components of the g is g cos theta and g sin theta. Now to find v square is the final velocity, that is v square is initial velocity is 0, that is 0 square plus it is going to the distance of the x from C to B, so 2g sin theta into x, that is equals to v square is equals to 2gx sin theta. Okay, now its kinetic energy at the point B is equals to half m into v square. What is v square? 2gx sin theta. Now 2gx sin theta. So 2 to cancel out, that is equals to mgx sin theta. Now let's write it. Kinetic energy at the point B is equals to, at the point B is equals to mgx sin theta. Now to find the potential energy of the object, to find the height, it is k, b dash k. Now to find the b dash k, how to find the b dash k? Now kc by bc is equals to, kc by bc, perpendicular by hypotenuse, is equals to sin theta. Now kc is equals to, bc means x, that is x sin theta. Now b dash k is equals to total height, that is h minus x sin theta. Okay, now the potential energy at the point B is equals to mg into h minus x sin theta. Now we have to calculate the mechanical energy. Write the theme the best. Here the mechanical energy at the point B is equals to mg, that is potential energy at the point B, mg into h minus x sin theta, plus kinetic energy at the point B is mgx sin theta. So here that is equals to mgh minus mgx sin theta plus mgx sin theta, that will cancel out, that is equals to mgh. So we have the potential energy at the point C is mgh, at the point B is mgh. So throughout its motion, the total energy, that is the mechanical energy, is a constant. Now let's to move to a problem. Need 2023. The potential energy of a long spring when stretched by 2 cm is U. If the spring is stretched by 8 cm, what will be its potential energy? And the options is given 4U, 8U, 16U and 2U. How to find it? The potential energy of the spring, that is the keyword. This is the potential energy of a spring is half k into x square. Okay, here k is the spring constant and x is the displacement of the stretch of the spring. Now let us consider it as u. U equals to half k x square. And now consider its final potential energy u dash half k x dash square. Now taking the ratio, we have u dashed by u, that is equals to x dash square by x square. Now what is x dash? X dash is given 8 centimeter, and what is x? X is 2 centimeter. Now that is equals to 8 whole square by 2 whole square, that is equals to 64 by 4, that is equals to 16. Now u by u dash is equals to 16, that is u dash equals to 16 u. Now the correct option is 3. So we can solve it easily. Now let's move to the next question, NEET 2021. What is the question? A particle released from the height s from the surface of the earth. Now let's draw. This is the particle. It is released from the height s. It is given at certain heights its kinetic energy is 3 times its potential energy. That is the condition. At a certain height its kinetic energy is the 3 times its potential energy. Let us consider that particular height is y from the ground. In the figure we consider it as here, that is y. Now the distance should be s minus y. Now let us consider at that point, that is b point. Its velocity is v. Now from the equation we have v square is equals to initial velocity is 0, that is 0 square, plus 2g into s minus y, that is v is equals to under root 2g into s minus y. Now what is the condition have been given? At certain height its kinetic energy is 3 times its potential energy. Now we raise it. At certain height its kinetic energy is 3 times its potential energy. Okay. Now the condition have been given. Kinetic energy is the 3 times of the potential energy. Now what is its potential energy at the height y? That is equals to 3 into mgy. Now what is its kinetic energy? Half m into v square. What is v square? 2g into s minus y. Now cancel the 2, here the m. So we have s minus y into gg will cancel out. So s minus y equals to 3y. Now here we have, that is the 4y is equals to s. So y is equals to s by 4. That is the height at which the kinetic energy is 3 times of its potential energy. That is here we have s by 4, s by 4 and s by 4. The three options we have the s by 4. So we have to find here its velocity. V is equals to, we have root under 2g into s minus y. S minus y is s by 4. So we have s by 4. That is equals to root under 2g into 3s by 4. That is equals to root under 2 to 4. That is 3gs by 2. Where is 3gs by 2? It is the 3gs by 2. So the option 1 is correct.